Welcome back, dear students. We are still on the abstract data type trees, which is very broad. Today, we are looking at a different type of traversal, which is different from the way the nodes are visited in pre, in, and post order traversal. And we are equally going to see how how to give the array representation of a binary tree. Now, that type of traversal is known as the level order tree traversal. In contrast to DFS, that is depth first search, because depth first search, pre, in, and post are grouped as depth first search. So in contrast to DFS, which does not depend on how the nodes are processed, but on level order, thus level order traversal, BFS, breadth first search. So what are we saying here? BFS depends on how the nodes are processed, but on the level order, that is, we process them level by level, which is not the case of DFS because DFS depends on the different arrangement, the position of the nodes. This method traverses a tree, we are talking about BFS. This method traverses a tree such that all nodes present in the same level are traversed completely before going to the nodes of the next level. That's what we call level order traversal or breadth first search, or traversing a tree in breadth first. Now, traversing a tree in breadth first order means that you will start at the root node, visit every node at the next level from left to right or right to left, repeat the step above till the last level. As simple as that. So this is the easiest traversal you can be given as question. NB. If the nodes at level 1 are visited from left to right, then the nodes at the subsequent level should be and must be visited in the same order. So you cannot traverse the node at level 1 from left to right, then those of level 2 from right to left. No, your answer is going to be wrong. Example, consider the binary tree below. Traverse the tree and output breadth first. So what do we have? If you want to output from left to right, so that my root is 1. From there, I have these two at the same level. As I'm moving from left to right. After the root 1, I have 7, 9 because they are at level 1. Then I move to level 2. I have 2, 6, 9. As you can see. Then I move to the last level, 5, 11, 5. So this is the output of the tree in breadth first from left to right. But if I'm going from right to left, I'm going to have 1, then 9, 7, then 9, 6, 2, then 5, 11, 5. Both answers are correct. But please, if you are being asked this kind of question, when giving your output, it will be good you precise the order, the direction in which you are going. Is it left to right or right to left? Although in some questions, it can be precise. Now, array representation of a binary tree. Array representation is another way to represent binary tree, especially useful when the tree is full, that is all levels are fully filled except possibly the last, which is filled from left to right. In this method, the tree is stored as an array. So we store the tree as an array. For any node at index I, the left child is located at 2i plus 1 and the right child is located at 2i plus 2. Root node stored at index 0, assuming that is the first index of the array. So that these are the three conditions you need to know. Paper 1, take note. You might be asked when representing a binary tree in an array, the left child of the node at index this, where is it located? You need to know. The left child 2i plus 1, the right child 2i plus 2. Now we move. When producing the array representation of a tree, we assume it is a full binary tree, and hence if a node is missing, its cell in the array remains empty. Example, using the binary tree beside, that is this one, produce its array representation. So this is what we have. Note, a full tree with level I has a total of 2 to the power I plus 1 or that minus 1 nodes. So if, for example, I have my greatest level is level 2, so it means that I have a total of 2 to the power 3, which is 8 minus 1, 7 nodes. Now, solution. This tree has how many levels? Level 0, level 1, level 2, level 3, meaning that I have 15 nodes. So this is my array with 15 cells. First of all, I have my root in the first cell, as you can see. I'm done with level 0. I come to level 1 now, 7, 9, as you can see. Then I come to this level. We assume that the tree is full. Normally, 2 was supposed to have his 2 children, as you can see. Sorry, for after 7, 9, we are here. The 7 has his 2 children, correct? 2, 6. Then 9 is having only 1 child. Normally, there was supposed to be a child here, so that cell will remain empty. So I'm supposed to have empty 9. That's what we have. I hope you know why it's empty, because we assume it is full. And if a node is missing, we consider it empty in the array. So I have, okay, the root. The root has its 2 children, 7 and 9, as you can see. 7 has its 2 children, 2 and 6. This is it. Then 9 has 1 child missing. That's why you see this empty space, and then the other child, which is 9. Then 2 was supposed to have 2 children, and they are absent, so I'm supposed to have 2 empty cells. That's what we have. 6 has his 2 children, 5 and 11. That's what we have. Now, this child of 9 that is missing was also supposed to have his 2 children. So I have 2 empty cells again. Before I come to 9 now, who has as child 5 and an empty. So I have 5 empty. So this is the array representation of the tree. So please, to easily understand, to easily produce the array representation, it will be good you use a pencil. You try and produce those different children who are missing, and from there you will easily fill this one. As the tradition says, it is very important that after going through a particular explanation, the best way to understand is by practicing. So guys, take this as exercise, and as a tradition, the solution will be posted in the WhatsApp group and the Telegram group during the weekend. The exercise, you have these 3 given. You have to produce the breadth-first output of the tree, and you give the array representation of the tree. In our next class, we are going to see another very important type of tree, which is the binary search tree. We shall see how to draw a binary search tree. We shall see the properties of a binary search tree. We are equally going to see how to draw a binary search tree when given a particular type of traversal. And we shall go further to see how to represent a binary search tree after the insertion and or the deletion of a particular node. Thank you for watching this video. Remember to like, to subscribe, and to share in order to increase our community. Thank you, dear students, and see you in the next lesson.